For our next example, we're going to rearrange these numbers from smallest to largest. Now, when I order decimals, I like to compare them vertically. So I'm going to write 9 and 200ths, 9 and 500ths, 9 and 461 thousandths, 9 and 7 thousandths. Now, just because numbers can seem longer does not mean that they are bigger or smaller. Now these two go up to the nearest thousandth, so I'm going to put zeros there so they have the same amount of digits to compare. Now we can think about this as looking at the smallest or the biggest first. Since it's smallest to largest, I'm going to look for the smallest number. So look in your first spots here. They're both $9 for sure, so 9 wholes. If I go to my next spot, I've got these zeros. That means that this number is bigger. That's actually the biggest number. $9.46 is bigger than all those. Okay? If I look at this next digit in the hundredth spot, 00 is definitely the smallest here. This is like saying $9 compared to $9.02, $9.05, $9.46. So lots of different ways to compare. Just make sure you slow down and look. So $9.07 is the smallest. So you can drag this in front onto Mobius. Done with that one, let's cross it off. The next one that I would have would be $9.02 versus $9.05 and $9.46. So 9 and 200ths is next from smallest to largest. My next one would be $9.05, so 9 and 500ths. And my biggest number, not because it's the longest, but because 46 cents is bigger than all of those. So 9 and 461 thousandths would be the largest. So you can drag and move them. Just double check. Did you do it correctly? Did it match the smallest to the largest decimals? Our last example is solving each absolute value problem, which also could be evaluate each absolute value problem or simplify. Now, first let's review what absolute value is. Absolute value is the distance away from zero. And we can have different types of directions, but distance is always, always, always positive. So here's my number line, here's 0. If I am asking the absolute value of 4, that's saying how far is 4 away from 0. Well, here's 4, and it's 1, 2, 3, 4 units away from 0. So the absolute value of 4 is 4. Now, the absolute value of negative 4 is saying how far is negative 4 away from 0? Well, it's still 1, 2, 3, 4 units away from 0. So the moral of the story is, whatever is an absolute value, you want to simplify it first by following the order of operations, and then after you're done, make it positive, because it's saying how far is whatever's on the inside away from 0. So for this first example, the absolute value of 2 subtract 7 plus the absolute value of 9 subtract 4. We're going to simplify what's on the inside. And lots of times I'll over-exaggerate those vertical lines so I don't get them confused with the number 1. All right, this inside, 2 subtract 7, well, that's not positive 5, it's negative 5. And 9 subtract 4 is positive 5. So I simplified the inside. Now we're saying that how far is negative 5 away from 0? Well, it's positive 5, so I'm going to make it positive now. And then I'm going to add the absolute value of 5. How far is 5 away from 0? Well, it's 5. So in the end, I'm really adding 5 plus 5, which has a value of 10. A very big common mistake that kids make with B is that they distribute into the absolute value. Well, first we have to simplify the inside. So this negative in front is staying there. That 3 in front is staying there. All right, let's simplify the inside. 9 subtract 12 is negative 3. 10 subtract 6 is 4. Now we're going to make it positive. So that negative is still in front. Now how far is negative 3 away from 0? It's positive 3. And then we have plus 3 times the absolute value of 4. How far is 4 away from 0? Just 4. Now that the absolute values are gone, let's finish. Here it's saying the opposite of 3. Well, that's negative 3. Plus 3 times 4 here is 12. In the end, let's do negative 3 plus 12, which is positive 9. 9 is our final answer for that example. Good luck with your homework.